Hey folks, and welcome to this latest episode of the SmallTechPodcast by Easy. I'm your host Raph, and today we're going to be talking about AI. Before we get going though, remember to like and subscribe if you like the work that we do. We're a small team, we'd really appreciate the support, it helps a lot. Leave us a review, and if you want to join us on an episode, we just released our first interview, and we'd love to have you on if you want to talk about building small tech products. So let's talk about AI. AI has been in the news a lot lately over the past year, 2 years, but something that I started to recognize recently is that as the hype grows around it, so do the misconceptions around it. And while I'm no expert in the mechanics of what goes on deep under the hood, I do recognize some things that people don't understand about what this technology is, and specifically the stuff that we're talking about these days. So a little bit of history. We've been talking about things that really are just different forms of statistical analyses as AI or machine learning or whatever for a while now. And so what we're calling AI at the moment is an extension of what we were referring to as machine learning more recently and big data prior to that. And it's mixed in with other concepts like neural networks and GANs and all kinds of other stuff. And I remember playing with tools based off of generative adversarial networks way back many years ago at this point. But they didn't enter this sort of hype cycle that we've gotten into with AI more lately. And I think the reason for that is the results, the outputs, the things that you got out of those tools, either from a consumer perspective, weren't as fun and exciting, and from a business perspective, were great, but they didn't tap into people's imagination in the same way that the tools that we have now do. So we've had AI being used to do all kinds of stuff, from predicting trends from large data sets to parsing audio and generating text in different ways for a while now. The thing that's changed in the past couple of years specifically is what we're now referring to as generative AI. And I think specifically there's two things in there that people are particularly enamored with and find fascinating to play with. One is the image generators. So being able to just describe something and have an image come out of that description. Until recently, there wasn't a great way to generate decent outputs for something like that. But in the past few years, the results have gotten way better than they were before. And of course, with that comes a whole slew of controversies around intellectual property and more. We're not going to talk so much about that in this episode, but we will talk a little bit about the mechanics of what's going on under the hood. The other thing is large language models, which kind of do the same thing, but with text. So you provide some sort of input. That might be a short prompt, it might be a long prompt, and basically you get something back that either continues a conversation if you're using something in a chat style interface with an LLM, think of ChatGPT, or it might just complete something that you started, though we're seeing less of that at the moment. Functionally though, under the hood, that's what even the chat interfaces do. And here's where we'll start to dive into the mechanics, because I've seen people, and I want to talk specifically to people who are not deeply technical. So if you're an AI expert or you're a developer who's really deep into this stuff, this probably isn't for you. And if you do keep watching, you might find yourself shaking your fist at the screen if you're watching, or in the air if you're listening, saying that's not quite right. And I think that's okay. I'm going to try and cover things in a way that I think makes sense for someone who is non-technical but is interested in what can be done with these technologies, or wants to better understand them, wants to understand how they might fit into a product roadmap, see what they can build with this technology, or even somewhat technical folks who just haven't played with it yet. I don't actually understand very well what's going on with the image generators. On some level, what I understand is essentially images are fed into the training systems. And don't think of them as being stored in there. It's more like information about the images that's being stored and correlated and mashed together into this system that can then correlate descriptions with those metadata about the images and spit out something that fits those correlations. So if you fed a lot of images by Van Gogh into one of these systems, and they're all described as Van Gogh, and they might say oil painting as well somewhere in the description. There might be descriptions of the types of colors and the brush strokes and all of those types of things that really define a Van Gogh painting. During training, basically what happens is the systems learn to recognize those similarities. Oh, we see things about the quality of the brush strokes and oil paint and Van Gogh. And it correlates that with with that style of painting, with the way that the pixels are basically grouped next to each other, the contrasts, the colors, the patterns, those types of things. And then it can apply that to something else. So if you have many images of dogs, when those are being fed in and it says Dachshund or Husky or Golden Retriever, and the shapes of the dogs are parsed and stored as metadata in this system, they're not storing the images of the dogs, but they're storing the sort of rough shapes and ideas of how a dog is or those dog breeds are. And then you can mash those together. And so if you have the shape of a dog, but the texture of a Van Gogh, you get a painting of a Golden Retriever in the style of Van Gogh. But of course, there's limits to how we describe images and paintings and all of these things. And so you'll find when you play with these tools that they come up with really weird stuff, and you can see that they don't really understand. And you can also see that they're clearly not copies because things come out weirdly. They don't make sense. And the tools are getting a lot better at that. But think of that as the way these systems work. They understand patterns, they understand metadata about these images, they bring in descriptions and keywords, and they mash those things together to deconstruct all of the training data and mash it into a correlational machine. And then when you provide a prompt, it goes from that sort of loosey-goosey something building back up on those correlations and spits out something that may or may not make sense. Of course, more and more they are making sense, and they're doing things that they're generating outputs that look really good. So do without what you will. Maybe that helps you understand a bit more of the context for the controversies, or it may give you some context for how to work with these things, but hopefully it helps. The other thing is large language models. You can think of it very similarly too. Basically, these systems during training bring in tons and tons of data about all kinds of written text from throughout history. Again, controversies around how those data are sourced. We're not going to dive into that. But basically, you have massive data sets of written language in various languages. And it is really under the hood just fancy autocomplete. That is basically what these systems do, but on a really large scale. When you're writing an essay, a paragraph you're writing is based off of the previous paragraph you wrote and the previous chapter that you wrote, or the research that you have put into that paper. Maybe you could imagine as being before that, further up the chain. If you had all of your research and your writing in one document, you could think of it that way. It's just you have all of these inputs, and then your next paragraph is predictable in a sense based off of the inputs and the previous writing that you've done. What comes next? Essentially, that's what these systems are trained to do. They recognize patterns in language. And so they know that if you have a paragraph about how playful dogs are, then maybe your next paragraph is going to be about the joy that they bring to their humans. something along those lines. And that would depend on the rest of the context of what you're writing. But they're not coming up with anything novel. There is some randomness in the system that is intentionally placed there. But it is really just autocomplete. And even when you do the chat interfaces, functionally what they're doing is still doing autocomplete. If I have a conversation with someone and I say, "Hi, how are you?" predictably, the response will be something about how the person I'm talking to is doing, and probably asking me back, "Hey, how are you doing?" I'll respond and we carry on with the conversation. They're encoded in the language that we've left strewn around the internet and through books and other media. So these systems find those correlations, they understand the patterns, they're trained on those patterns. If there's one word in front, then what's the next word that comes after? And fundamentally, they just do long chains of that based off of the training data. So when people talk about these hallucinations, for example, I think it's really important to understand that the outputs of these systems are just word predictions. They're not knowledge predictions. They're not logical predictions. They don't understand what's going into them, really. You could have philosophical debates about whether we understand what's going into our brains as we hear words and we parse them. I'm not going to go into that, but the mechanics of it is, here are some words. What are the next logical words that should follow? And that also means that these systems don't have real-time access to data. Now there's a caveat there, and we're going to talk about that in a second. But if you're just chatting with something like ChatGPT or Claude or any of the other ones, and you're not using a version of them that is connected to the internet, their data that they're trained on is potentially old, and it doesn't have context. Now, there are techniques that you can use and that are being used by all kinds of systems, including search systems that use AIs. So if you're thinking about using Bing Chat, or if you're on a paid tier of ChatGPT, you can also ask it to make sure that when it responds to use sources from the internet. Or maybe you're using a search system like Perplexity. All of those systems use a technique called RAG, Retrieval Augmented Generation. Now what that does is it uses, I'm going to say algorithms, basically methods to figure out what is most relevant based off of your query in what fundamentally looks like a traditional search index. If you just type into Google recipes for apple pie, it will go find things and it'll give you a list of results. Now what Bing Chat and ChatGPT, when connected to the web on the paid tier, or Perplexity do is they kind of just do a normal web search, and then they add that text into the frame, the context of your question. So when they respond, it might not be there literally, but under the hood what's happening is they're pulling paragraphs from those sources and saying, okay, if you asked, how do I make apple pie? Let's go fetch these recipes, add them into the context in a way that's hidden, and then respond with that context. So now when the fancy autocomplete keeps going, it has both the context of the question, but also those paragraphs about how to bake an apple pie. And so when it responds, it will give you stuff that's a lot more accurate. Now you can also get fancy with your prompting and basically tell it, do not use anything other than valid sources, and then it should understand from the context that whatever comes back from a search is the valid source that you're looking for. You can also tell it only return results with URLs that you can visit, so you can then go validate those sources yourself. But you can imagine how you can integrate those types of techniques into your own products. Let's say you've got a note-taking app with a database of notes. You need a system to parse a user's input who's asking, what am I doing on a Thursday? So you might take that input, convert that into a more standard search algorithm. You say, what date is Thursday? Filter out notes, grab the text from those notes, and then tell the large language model that you're using, hey, this person wants to know what they're doing. Here are some notes that are relevant to this coming Thursday. respond to them only with that context, do not include anything else. And now you return that response to the user. So those are some ways to think about what's happening in large language models, how they can be used appropriately to reduce hallucinations, what is really happening when you interact with one of these models, and how they may or may not make sense in a product. Now, there's so much that we're going to figure out as a society over the coming years about how training data should be sourced, how these systems should be used, how they should be regulated. But I think personally that there's something really interesting and exciting about the way that these systems work, particularly large language models, because they fundamentally become a different way of interacting with information and knowledge. The way I see it is, as long as they're paired with search or search-like systems, they become a new interface for the data that we store, the stories that we have, the knowledge that we share. There are valid debates to be had about how the training data should be sourced and how we should oversee the training of these systems. I think it's undeniable that there's value in being able to parse language better than we have been using computers, which fundamentally have not been able to parse language well so far. And I think it just opens up so many possibilities for things that we can create, because so much of what we are as a modern society is encoded in language, and language that is stored in ways that can be used to build these systems. Yeah, I think we need to be careful. I think there does need to be regulation, primarily about the outputs. I'm less worried about the inputs. And I think there need to be best practices in place for practitioners who want to use these systems within their own products. But hopefully this episode helped you understand what's going on under the hood, what are the possibilities, how you might want to engage with these tools. And yeah, I hope it was informative. Alrighty, thanks for listening, folks. If you enjoy this stuff, please subscribe on YouTube and subscribe to the podcast in your podcast app of choice. Also, leave us a rating and review. Really helps us out. We'd love to hear what you think, and I'd really personally love to have you on the podcast. I'd love to talk to other people about this stuff. Also, make sure to sign up for our newsletter, where we'll be sending you all kinds of great info about how to build a small tech product. There's going to be videos, blog posts, episodes of the podcast you may have missed, and plenty of other stuff. So head to smalltechpodcast.com and subscribe there. So that's it for this week's episode, and we all want to do good in the world, folks, so go out there and build something good. See ya.